continuation with the banking application, right? So we are to process the accounts, we have processed the customer, we want to process the movement now, the basic transactions processing we are going to see. So first we are going to understand the basic, right? And then we will use the recycle queue component and the significance of recycle queue component in the processing of the database kind of process, right? And the continuous processing is very important component basically. So let's understand it. So first of all we are going to see the processing of the movement data, right? The transaction data. So we know that there are transactions are going to be received in the queue, right? AICDL queue, movement feed, right? Movement queue will be there, and based on that we will have a normalized component in the sense of based on uh, the type of transaction, right? So there will be a credit and debit. So the amount passes from one account to another. So for a particular transaction, right? So there will be a two things will happen. The amount will pass from one account to B. So the credit happens in one account and debit happens in another account, right? So when we in whichever account the money comes in, the credit transactions should be there. So therefore, we use the normalized component to have two transactions for a particular transaction movement. That's when we use the normalized components. We will create the two and based on the account movement type we will assign. So this kind of data type we have, right? Movement type in and out of money, right? So then we will use the existing for a particular transaction, right? We will use the whether the exist account is existed or not. If that account is not existed, then we will not, use that account further. Then we will use the validation of the movement. If the movement is valid or not, right? Right? In the sense of transaction ID is valid or not. If the transaction ID is valid, otherwise we will use the all the records in the publish rejected transactions. We will say that let's create a queue and use that queue to publish the data which are invalid movement or invalid transaction. Okay, so for example invalid transactions or invalid movements, we will publish all those into that queue so that we will use that in logging purpose or maybe further analytics purpose. Okay, and in this flow, we will have all those valid account and valid transactions, and then all those transactions we are going to pass into the multi-publish. I talked about this multi-publish earlier, right? If there are multiple graphs which are publishing the data into a certain queue, and right, so we will use the multi-publish. So I have used multi-publish already in the which graph I used. I used into the customer processing graph, right? So so all those three graphs will run in parallel, right? Therefore, you know, so we can use the multi-publish so that if anything is published multiple by the multiple graphs in the same queue, then the multi-publish is the component for that kind of queue publishing. Okay. Now for we will have the if there is an amount valid, then we can use the data for the maybe insert and update for the all those transactions. Okay, so this is simple basically. If we need to you know check the continuation in continuation, here we have used the existence of the account, right? If the account is not existed, let's say for 5 accounts in this flow, and after some times those accounts come into the system by what graph? By account processing graph, right? So this is also running, right, in parallel. I said this is also, but at the time, let time t1, this account is not existed, therefore the account is dropped, right? And it will not go into this flow, never, right? But the transaction has been received, but the account was not there, therefore what happens is like it is getting dropped. So in those kind of situations, what is the way, right? So the way is recycle queue. So the fundamental of the recycle queue is, let's say at t1 time we don't have this, but let's try after some time or in the next checkpoint, let's say. Okay, so in that kind of situations, right, we use the recycle queue. What it does is, so there is an So what we will do is the leftover records which are not matching in the account table in the database at that point in time T1, what we will do is we will publish that record into the this queue, transaction recycle queue. So this queue will be published. We will have a component recycle queue. There is a parameter called queue, and we will specify this. And all those records which are not existed at that point in time, let's say T1, we will publish. And next checkpoint, we will concatenate it. This will be subscribed by okay in the next for the next checkpoint. Okay, and it will be tried again. Okay, let's say it did not receive again back also for the same account, it will again will be published, and again all the record will be subscribed to the next checkpoint. So that kind of arrangement, if we need that, we will use the recycle queue kind of thing, right? So it is very very helpful in case of continuous graph, right? Okay, otherwise it's very difficult to do that, right? We will create some kind of queue, or maybe that queue can be read again back or something like that, right? So similarly, there is a recycle queue. We can attach it and we can try it again, or we can publish that data into this queue first, and then the subscription happen in the next checkpoint basically from this queue. Okay, and let's say at certain point in time, let's say we have kept nth tried, and some records are never going to come back, then we will have kind of time limit, or maybe certain point in time, let's say I tried after 10 days, we can drop all those records also. Okay, that kind of arrangement can be done. So otherwise, rest of the graph is same, right? We can the validation of movement, then the replicate, the update, and the multi-publication, and the rejection of publishing the rejected record, right? So everything else remains same. So the mechanism is like uh, so this is a very very important mechanism, so that in the continuous graph itself you can take care of the other things also, so that our graph is reliable, our graph is uh, uh, functioning smoothly. Okay, and we don't have to maintain multiple things with respect to it. Okay, so thank you so much. Please subscribe my channel, and we are going to see now what is we are going to check upon is like I'm going to touch upon a few more component, and then we will talk about the optimization of this continuous graph, and the recovery and optimization both are important, and how we shut down the graph is also important. So we will talk about all those commands also, and how it happens when the shutdown happens, right? When you supply the shutdown stop. So there are three ways of doing the shutdown and stop, right? So we will see in the next videos. Thank you so much.